Have you ever looked at a really complicated electrical circuit and wondered how you could possibly analyze the current or voltage at just one specific component without getting lost in a maze of calculations? Well, applying Thevenin's theorem to circuit networks is incredibly valuable because it simplifies any complex linear circuit into a much easier to analyze equivalent circuit, specifically a single voltage source in series with a single resistor. This transformation allows you to quickly determine the behavior of any connected load. The core reason this works lies in its foundational principle of reducing complexity. Any combination of voltage sources, current sources, and resistors, no matter how intricate, can be represented by just two components as seen from two specific terminals. This is based on the concepts of linearity and superposition, essentially summing up the effects of individual sources and resistances to find a single, powerful equivalent. This means you only have to analyze the simplified circuit when you change the load, rather than reanalyzing the entire original, complex network every single time. To apply this practically, you first identify the part of the circuit you want to analyze as the load, and then separate it from the rest of the network. Then, you calculate the Thevenin equivalent voltage, which is the open circuit voltage across the terminals where the load was connected. After that, you determine the Thevenin equivalent resistance by looking back into the network from those same terminals, but with all independent voltage sources short-circuited and all independent current sources open-circuited. This elegant simplification is especially powerful when you need to study how a circuit behaves with various loads, or when trying to achieve maximum power transfer to a load. For instance, in an amplifier design, understanding the Thevenin equivalent allows engineers to optimize the load impedance for the most efficient signal transmission. It is a fundamental concept that provides a deeper insight into circuit performance beyond just finding numerical answers. Ultimately, Thevenin's theorem empowers you to streamline your circuit analysis, quickly predict how different loads will interact with a complex network, and gain a more intuitive understanding of the underlying electrical principles at play, making complex problems much more manageable.